My name is Myles Sutherland. I'm the CEO of GeoCam, one of the original founding team. And with me today, I have John Schroder, CEO of a company called GeoSolv. We've known each other for a while. We've been working together, focused around the role that reality capture, like the technology that we build at GeoCam, can play in the fibre industry. And John's been kind of helping teach us a lot about the industry. So I think today's going to be a great session. You've got two people with totally different backgrounds coming together. And as we go through today, fire in questions. We're going to do a Q&A at the end, and we'll do our best to answer them. If you want to get hold of us, just got our emails up there. Feel free to connect with us. It's the best way to get hold of us. Okay, so let's start with a little bit about GeoCam. And you may not be familiar with us. If this is new to you, there's a little bit of introduction stuff here. If you're on our previous webinar, you may have seen pieces of this, so apologies for that, but I just need to set the scene here. So we build machine learning powered street level and indoor imaging and mapping technology. The technology is all based around using photos. So you might be familiar with LiDAR based capture systems, terrestrial based scanning, indoor based scanning. Kind of similar in terms of the outcomes at some level, but we do it all using photos. We actually design and build all of our technology. So we build this 360 camera you can see on the screen here. It's a GPS, GNSS, I should say, enabled, ML enabled camera. I'll talk a little bit more about that in a second. We build a processing engine, machine learning engine that takes all the photos and does some smart things with them, figures out where they are in 3D space, both using the GPS, but also in GPS or GNSS denied environments, so under trees and around urban and canyons, tunnels, and most importantly, inside of buildings at any scale. Today it's not about the indoor part of what we're doing, but you'll see more of that from us over time. There's also a set of applications that run inside of our software that you can work with the imagery. So there's a capability to view in the web the images along with your maps and 3D scenes, and then also we have an editor capability that you can create your own data. Okay, so why do we build GeoCam? Well, yes, it's about photos, and there's a ton of value out of working with imagery. But fundamentally, this is not a GoPro type approach where we've taken a consumer camera and trying to just get imagery. This is a system that's been built for you all who are trying to actually build map data. And you're going to see what John's been doing and how this impacts his business. And like I mentioned earlier, this works out in the outdoors, so you can mount this thing on vehicles and drive it around. You can also walk it through indoor spaces. But this is primarily about building map data. So points, polylines, polygons, things that you want to put into your GIS or mapping system. Okay, 360 camera. It's designed to be pretty universal. Can be mounted in almost any way that you want. Typically, it's mounted on a tripod that comes with it, like you can see on the screen there on the left-hand side, or it's on a monopole when it's walked around. Can go on all sorts of different vehicles, not just sort of your SUV like you see here, but on ATVs. You can do off-road captures. It can be used upside down. You can tip it upside down. That's useful if you want to collect in and around and under certain objects. All sorts of different ways to use the camera. At the core of our system is an image processing engine. This is the visual positioning and mapping engine. It leverages the GNSS technology, real-time kinematic in the field, and then post-process on the server side. But ultimately, it's the visual positioning engine that does most of the work here. That's working out where the photos are taken in 3D space. I'm not going to get deep into this subject today. In the future, we're going to start building some additional webinars and content that will touch in like, what's the difference between this and LiDAR at a technical level. Today's going to be more about the business side of things as it relates to the fiber network design use cases. John will comment on this, but the camera collects data at a really high frequency, so a 2-meter interval when you're driving. That's got a lot of value. Two, you can see a lot of objects, and we spec it at 10 centimeter accuracy. Depending on the environment, that can vary a little bit. Often it's a lot better than this. In some cases, depending on how long it's been in a GNSS denied environment, the data can start to degrade a little bit. But overall, if you're doing large scale street captures, generally going to hit 10 centimeter accuracy across 95% of the scene. One thing that is very important to us, so we do run machine learning across that whole platform for various reasons, but one of them is to blur out certain objects from the photos. So we do blur out the vehicles and people. Built our own model for this, and it runs on the server side at the moment, but I think over time you'll see us push this and run it in the camera. We've built the technology to be able to do that. It's important for being compliant with a lot of the different privacy rules and regulations, especially when you get inside of buildings or on somebody's property. Okay, so really the first place that you start to work with this data is through the GeoCam viewer. It's a web application. Your organization and users can authenticate into this, and it gives you kind of like own street view of the assets, the roads or the environment, wherever you took the camera. And this is built so that it can work really closely with your Esri ArcGIS mapping system, which most folk in the world are using. So you can search features, quickly locate them. You can even edit existing ones, so you can go in and update attribution, update values about certain objects you see in the images. It's quite a useful workflow. And most importantly, you can actually use the dynamic URLs with this application to share specific views to people. So John's team does this. They're out looking at some pole, and there's a debate about the construction process based on the design. They're able to share with each other specific views and then have a conversation and start to talk about the decisions that were made in designing the fiber network plan from the imagery. Okay, so I just want to touch a little bit on how we work with the Esri ArcGIS system. This application does actually use the JavaScript API, and it works with your ArcGIS Online or your ArcGIS Enterprise system. We are not in the business of building the geospatial data storage ArcGIS type system, so this is the best way to go. It gives you a lot of capability to be able to manage the map data production workflows, but also to be able to view pre-existing data. You may have data from a utility, like an electric utility, that you're going to use in support of your design process. So you can quickly assess the quality of their data against the imagery before you start to update it, or just make your own data and use the existing data sets as a reference. Okay, so at the start of this session, I had this nice little video that you all saw. It looks pretty amazing. We've got GIS vector features that are overlaid, sitting inside of orientated imagery. This is our tool we refer to as GeoCam Desktop. It's a tool that you can go in and create points, polylines and polygons directly into your ArcGIS feature services. And you have a lot of capability in doing this. Effectively, it's triangulating objects out of multiple image views. We have some other tools that make this more efficient for managing just the general editing process. But you can quickly go through and map poles and start to create connectivity models. Like in this case, what John and his team does with us is that they build out existing connectivity between the poles. That could be utility, streetlight poles, anywhere that's already got a connection, somewhere that's previously probably been permitted and is ideal for using as part of a design. So in doing that, his team has been able to go back and forward and manage that process in detail. Everything is kept in synchronization with their feature services that are running in their ArcGIS Online account. So they can actually edit in two ways. They can edit in the ArcGIS system and see those changes back in the imagery. They can also bring in their designs and view the designs back against the imagery. Okay, so that's a little introduction to GeoCam. And I think over time you're going to see more and more from us about the system and how it works and different components there. But I'm going to hand over to John now, and he's going to start to talk you through how he's been using it and some of the value that he's getting from the technology.
Hey everyone, thanks for joining us today. My name is John Schroder and I am with GeoSolv. I've been working in the fiber design for years now, and in that time, I've seen the industry evolve in some amazing ways. But no matter how many things change, one constant remains. Fiber design projects are complex, detailed process that evolve a lot of moving parts. Today, I want to walk you through how we've been using reality capture technology from GeoCam to simplify and streamline the whole process. We're going to talk about everything from planning and field data collection to design and quality control, and how GIS plays a central role in making sure everything comes together smoothly. Whether you're new to fiber design or you've been around the block, I think you'll find something useful in today's session. So let's get started. Okay, let's start by breaking down what it actually takes to design a fiber network. It's not as simple as laying a cable. There's a whole series of stages that we go through. You've got your planning, data collection, permitting, fiber design, construction, and of course, quality control. Each one of these stages is critical, and if one falls behind, the whole project gets delayed. GIS has become our lifeline for keeping these stages organized and efficient. So how does GIS help us in fiber design? First off, it gives us the power to map out the most efficient routes for fiber, avoiding areas that might cause issues later on, like utilities or environmental sensitive zones. It also helps us visualize the terrain, which is especially useful in rural and urban environments where laying fiber might be more challenging. GIS gives us the big picture, but it also lets us zoom in on the small details that can make or break the project. For example, in urban areas, using GIS means we can identify existing utility poles and underground utilities to avoid delays in construction. Or in rural settings, GIS can help us figure out how to navigate through long stretches of open land without needing to redo the design later because of unforeseen obstacles. This keeps our projects on track and within budget. Now, one of the biggest challenges in fiber design is field data collection. I'm sure a lot of you had to deal with this before. You send teams out into the field to collect data over long distances. Often in hard to reach places, it takes time, it's expensive, and it can be tricky to coordinate, especially if something goes wrong or needs to be revisited. If you look at this slide, here are some highlights of stats that I've witnessed on the GeoCam projects that I've worked. This is where GeoCam really shines. Instead of sending out large crews to manually collect data, GeoSolv deploys one person with the system to capture high resolution street level imagery of the entire area. And the best part, all of this data is geo-referenced, meaning it's super accurate and easy to work with back in the office. No more guesswork, no more second guessing measurements, no more calling a field guy. See if this is what he meant. If you think about that, how much does it change the game? The traditional workflow, you may send out a team of 4 to 5 people over the course of multiple weeks to gather data. With GeoCam, GeoSolv is able to send out one person to collect the data in a few days. That's a huge reduction in project timeline and labor costs. This accuracy is better than what we gotten from our manual collection. Plus, it is safer not having multiple people in the field for extended periods of time. So here's one of my favorite things about the GeoCam system. It's simple to use. We can ship the camera to our remote team members, and with really easy mounting system, they set it up on a vehicle, and in no time, they're ready to collect data. It's practically plug and play. No technical expertise needed, no complicated setup. Once the camera is mounted, the team can get started and capture data right away. And when we say we don't need a full crew out there, we really mean it. One person is all it takes to capture data. We typically send teams of 2 just for assistance and looking at other areas of interest, but that means fewer people in the field, lower travel costs, and faster project timelines hitting your schedule. We've seen projects where after receiving the camera, the field team had data ready for use and analyzed in less than 2 days. You can't beat that kind of efficiencies on these large projects. Another great example of this efficiency on a recent project we did in a large capture of an urban area. We had one person on this project. They captured all the area in 5 days. That would have been a logistical nightmare sending a full crews to access this area. Within a few days, we had all this data we needed to get started on this project to start the permitting and design process. If you work on rural fiber projects, you know how tough it can be to gather accurate design data. You're dealing with long distances, tough terrain, and not great connectivity. On top of that, when you collect data manually, it's almost impossible to validate it remotely. You have to go back out and recheck things if something doesn't line up or you missed an area. That's time consuming and costly. Thanks to GeoCam, we are able to capture this high quality data right from the start, no matter how remote the location is. We're creating the imagery that is precise. Our fiber designers in the office can validate it without ever setting foot in the field. This cuts down on the need for repeat visits, saving time and money and project timelines. Let's face it, in rural projects, that's a big deal. Another thing that's really helped us improve the efficiency is sharing this captured data and imagery with our clients through a viewer. This allows the client to participate in the validation, quality control right alongside us. They can look at the same data against the same geo-referenced image from street level views and confirm that the design is what they want. If they see spots of any issues, we can address them immediately instead of waiting until a later stage or a revisit from the field. For example, a recent project, we were able to share the viewer with our client's team. They didn't have to be on site or go to the field. Instead, they were able to review this imagery against our design and provide feedback via a web-enabled notes layer. This sped up the QC process, and they were confident in everything was accurate before we moved forward to permitting and construction packages. This kind of collaboration is a huge time saver. The client gets to be directly involved validating the data, seeing the current environment, which speeds up the process, but also builds a trust and ensures that everybody's on the same page throughout the entire project. Another huge benefit to the setup is how seamlessly it works with Esri solutions. For those of you who use and work in GIS, you know how powerful it is for managing and visualizing data. With GeoCam, after we capture and create the data, we can upload it to ArcGIS, and suddenly the whole team has access to it. This makes collaboration so much easier. Our fiber designers and project managers are all working off the same up-to-date data. So if something changes in the field due to a conflict, we discover that a route needs to be updated due to a utility issue, we can make that change in real time. It pushes the updates to everyone immediately. No lag, no delays. Everybody on the team is on the same page. One of the things that we really pride ourselves on at GeoSolv is our flexibility. We know not every project is the same. Some are large and complex, while others are smaller and more straightforward. So we've created simplified project models that allow us to offer services tailored to your specific needs. Maybe you need to help with field data collection, or maybe you're looking for full design support. Whatever stage in the project you are in, we can step in and provide exactly what you need, no more, no less. This helps you cut down on unnecessary costs and stay focused on really what matters on your project. We recently worked with a client who needed assistance on a large urban HLD build with multiple vendors. They wanted to ensure their data was accurate along with assisting in the design. We stepped in, completed HLD of nearly 160,000 passings and validated everything to ensure data quality. And they were able to complete the project on time and on budget. Thank you for joining us today. I've hoped you gained insights on how to use reality capture and GIS on your fiber network project. We look forward to taking any questions that you may have after this.
Awesome. Thank you, John.
Yep.
So we're just going to take some questions. And John, I've got a question for you that's come up here.
All right, I'm ready.
How do you think about dealing with the complexity of deploying the cameras? Like an example, the question here is dealing with weather. What's sort of the challenges or the restrictions about running the cameras that you see that you face with general weather that you have to avoid?
Yeah, so obviously weather does play a role in when we deploy the team out. We monitor what the forecast looks like. If they have 5 days of rain, it probably isn't a great idea to go there. So we're able to be nimble and prioritize other areas that the forecast looks good. If it's raining, we don't run the cameras in the rain. You have to stop for those instances. But all in all, the ease of shipping the camera allows us to be a lot more nimble. We don't have crews essentially. We don't have crews essentially in the hotels in inclement weather.
Okay, thank you. Another question here about the data side of things. Like someone's asking about how to manage all the existing data and updating it when you have the new data. What's kind of the system of record that you use for location?
So we operate everything within our Esri online system. So we create a existing records layer that really guides us on our planning of the projects. From there, when we go out and create new data, it really depends on, or after we drive the projects, we focus on, do we want to update existing records or do we want to create data and append? So it's really a project by project basis, but for sure, Esri, our online account, is what houses all of our data and manages it from there.
Awesome. I got a question here that I'm going to take. How much can you cover in a day with the cameras? So, I mean, I have my perspective on it, but so I'll share that first. And generally, you can drive any speed on the road. So, often doing surface roads or rural, regional roads, you're driving at lower speeds. You can technically drive on freeways and the highways and run at 75 miles per hour if you want. So the total number varies dramatically. I think when we're talking about fiber, most of this is getting done on surface roads or rural roads. So it can be anywhere from 50 to 100 miles of center line that might get driven in a day. Obviously, naturally, you're going to loop around and double up on certain roads, cul-de-sacs, things like that. When there are multi-lane roads, almost like a regional highway at some respects, then probably best to drive on both sides. So drive one direction in 2 lanes, and then the 2 lanes going the other way, come back along. So that's kind of how that works. But yeah, if you get on a freeway, you can carve off a massive amount of distance really, really quickly at 75 miles an hour. Okay, so if you have any questions, feel free to connect with us. The emails are up on the screen at the moment. It's Myles at geocam.xyz and John at geosolv.io.
We have a question in the Q&A. Adam asked if we can process house numbers that are visible on the house or mailbox and update address points collected. So technically, yeah, anything you see within the viewer, you can validate that information, right? Challenge comes if there's a parked car, is it 100% coverage to get those address points? You know, it's also a challenge on in the fiber world specifically, Adam, if you're trying to validate multi-dwelling units, looking at different meters and things like that. So the answer is, if you see it in the viewer, you can validate it.
Yeah, and it's definitely possible. Like, you can walk with the camera. So can drive along the streets and then can walk with the camera down sidewalks and different places as well. So it's a 36 megapixel sensor, and you can see quite a bit information on for addressing, but in some cases, yeah, you're going to have to maybe get out or use a totally different approach and technique. Oh, excuse me. Okay, so awesome. Great questions. Thanks for the session today. John, always a pleasure to work with you. Appreciate all your insights and experience. Again, feel free to connect with us or emails, and we're looking forward to chatting with everyone in follow-up. Thank you very much.
Thanks, Myles.